chemicals which are strong, which are very concentrated, that are very harmful, right? Okay. Okay. Let me just give a quick recap of what we talked about. Acids, right? Like we know it's sour, it's corrosive in nature, right? And it turns blue litmus paper into red, right? Apart from these properties, one more thing we needed to know that one thing common in acid is that acids contain hydrogen in them. All right, acids contain hydrogen in them, right? And acids are always found to be in liquid states. Acids are always in liquid state. So if I have got a acid, okay, and if I take out water from it, if I take an acid that is in liquid state, and if I were to take out water from it and I make it dry, this acid is not dry. And now if I were to bring a litmus paper near it, will the color of the litmus paper change? Yeah. If I were to bring a litmus paper, will the color of the blue litmus paper change? Yes, Sundus, are you able to listen me?
Yes, sir.
Okay. See, this is a blue litmus paper, right? And we know acids converts the color of blue litmus paper to
Red.
red. Now here I have taken a dry acid. Basically, I have evaporated the water out of it. Now, if I were to bring up blue litmus paper to it, suppose I have taken a powder of dry acid, right? Now, will this dry acid convert the color of blue litmus paper to red? No. The answer is no. Getting it? So
Yes.
litmus paper always works in solution form, in acidic solutions or basic solutions. Getting it? Yeah?
Yes.
Okay. Now, further, we also talked about what are the safety measures. Okay. So what do? Do we add acids into water or water into acid?
Acids to water.
Acids into water. Very good. All right. Then we also talked about bases, right? Okay. Can you list me some of the examples of strong bases? There are weak base and a strong base, right? We talked about some of
Sodium
them.
hydroxide.
Sodium hydroxide or
Hydroxide.
hmm,
Calcium hydroxide.
calcium hydroxide. Okay. What else?
Aluminum hydroxide.
Okay. These the examples now you are giving me just normal example of bases. Like in the previous class, I told you, like see these examples here. These one, sodium hydroxide here, ammonium hydroxide or calcium hydroxide, right? Or you were to take potassium hydroxide, potassium hydroxide. These were examples of strong bases. Let me write it on a fresh page. So here, Sundus, I'm giving you a fresh example of weak and strong bases. You have to memorize them. All right. Okay. Has Vaika joined yet or not?
No, sir.
Not yet, no? Okay.
Yes.
By the way, after your class 10th, okay, in which field you are interested to go? Which field you are interested to opt after your class 10th, huh?
I am confused into, like, I want to be a veterinarian as well as architect. So I'm very confused in those both.
Okay. Okay. Which subject do you find more interesting? Is it maths or science? Right now, no, the thing is, Sundus, that you are in class 8, right? And it is the time that you can brush up any subject you like, right? Like if your fundamentals in maths are strong, you have enough time to make it strong. If your fundamentals in science are weak, you have enough time to practice on that as well, right? So don't decide your stream after class 10th based on the subjects in which you are good at, right? So it should rather be decided on your interest. So what are the field like, as you said, architect and veterinary.
Veterinary.
Okay, okay, okay. Apart from these, any other options?
No.
No. All right. Okay, it's good that you have at least two options in mind, right? Sodium carbonate. So these are the examples of strong bases and weak bases. You have to memorize them. All right. Okay. Some important things out of this here, right? Like the washing powder which we use at home. Washing powder that we use is an example of base. Getting it? That is also an example of base. Okay, and if you ever take
Yes.
it in your hands, it is very soapy to touch, isn't it? Right.
Yes.
Mhm. Okay, so sodium hydroxide, take this sodium hydroxide here. Okay, sodium hydroxide is commonly called as caustic soda. Getting it? Sodium hydroxide is commonly called as caustic soda. Okay, getting it? So these questions
Yes.
might be asked, like which chemical is called as caustic soda, which base is called as caustic soda?
Sodium
Hmm?
hydroxide.
Sodium hydroxide. Okay, and what about Na2CO3? This here, sodium carbonate. The formula of sodium carbonate is Na2CO3. So this sodium carbonate is commonly called as what? Baking soda. All right, is commonly called as baking soda. So the baking soda which we use for the purpose of cooking, it is basically Na2CO3. Getting it, Sundar?
Yes.
Okay, so hope that is clear. Baking soda and caustic soda, remember them. Okay, and sodium hydroxide, by the way, it is NaOH, right? Okay. So one more important thing, few moments ago, as I said that acids contain hydrogen atom in them, that is H, H atom in them, right? And while the bases will contain hydroxide in them, bases consist of OH, that is hydroxide. Okay, so these are not basically taught in class 8, but still these things will help you in future. In class 9th and 10th, you will be studying about them. Getting it? Okay,
Yes.
all right. Any confusion so far?
No.
Okay, then we also talked about the neutralization reaction, right? So in the neutralization reaction, basically acids and bases reacts to give out water and salt, right? So here you will be getting water as well. Getting it? Okay.
Yes.
And this salt here is basically a neutral product, neither acidic nor basic in nature. Okay. All right. So here are some of the questions which you need to solve quickly. Okay. Also, Sundus, while in the class, you are required to keep your camera on. All right. Okay. That is basically to take care your attentiveness in the class. Hmm. Okay. Can you see the questions properly?
Yes.
Let me mark them. Hmm. Yes. What are the answers? Yeah, Sundus.
What, sir? No, I'm
See
doing
the.
it, sir.
Okay. Okay. No need to write the answers in chat box. Okay, just give me the answers. All right.
Done.
Okay, what is the answer of first one?
The first one is sodium hydroxide.
Sodium hydroxide. Okay, good. Vaiga, where have
Sir,
you been?
Good evening, sir.
Good evening, good evening. Okay, class has been already started 15 minutes ago. Where have you been, Vaiga? Okay. Anyways, see, we were just revising the concepts. Okay, and we have come to discuss these questions. So you also attempt these questions. All right.
Okay, sir.
Okay. Second one, Sundar, what is the answer? You also tell me the answer, Vaiga. Acids, right? Acids are sour. So basically,
So,
any
yes.
food or vegetable that tastes sour in nature, it must be having acids in them. Okay, third number.
B. No
B,
change
blue
in color.
litmus to red. B, okay, good. No change in color. Since it's a
Already
B,
the
sir.
neutralization.
neutral. Very good. Fourth one,
And base. It's A.
it's a that is neutralization reaction. Okay. All acids contain
Hydrogen.
hydrogen. Okay. Okay. So Vaiga, we discussed one more thing in related to acids and bases, that all acids contains hydrogen in them. Okay.
Okay, sir.
And all bases contain hydroxide, that is OH in them. So
Okay,
all
sir.
bases will have OH in them. Getting it? Okay.
Yes, sir.
Okay. Now the second one, see this one.
It is antacid.
Antacid. Very good. Okay. Lactic acid is found in?
Orange, I think so.
No. Vaiga?
Yes, sir.
Lactic acid is found where?
What, sir?
Lactic acid. Question number, this question here. Sundas?
Is it apple?
No, look. Apple or
Then
orange,
vinegar.
or these two contain citric acid in them, right? And vinegar consists of acetic acid. And this is curd here, right? And do also tell me which bacteria helps in the formation of curd.
I didn't quite
No, I
understand
guess,
the question, sir.
My question is that,
fungus.
no, my question is that which bacteria helps in the formation of curd?
Fungus.
No, it's a bacteria. Bacteria and fungus, though are complete different classification of microorganisms.
Oh, okay, so bacteria. Okay.
Okay, there's a bacteria by the name of lactobacillus, guys. Lactobacillus, right? So this lactobacillus bacteria, when it acts upon the milk, okay, when it is present in the milk, it will convert the milk into curd. So, and also it is due to the presence of this lactobacillus bacteria in the milk tastes sour. Basically, the curd tastes sour. Okay, and the acid that is formed by this lactobacillus is called as lactic acid. Hope that's clear.
I like we in curd we use milk, so milk has lactic acid, so that's why curd is a lactic acid.
No, naturally milk doesn't contain this lactobacillus. Okay, naturally milk doesn't contain lactobacillus. We have to add curd into the milk, okay, and let it overnight. Okay, then the formation, then basically lactobacillus bacteria starts to reproduce, and the whole milk is converted into lactobacillus, right? And naturally, lactic acid is found in milk, but this lactobacillus further propagates the formation of lactic acid in it, right? It basically increases the production of lactic acid in it. Getting it?
Sir.
Okay.
Yes, sir.
Yes.
So that's why the question is na curd. Otherwise, option would also have been milk, right? Okay, so if the option was also milk, then you guys would have to tick on both of them, curd and milk as well. Yeah. Okay.
Yes.
Now let's talk about the indicators, right? What are the indicators? Like as we said that we can't keep tasting every acids and bases or salts to check for their property, right? That's why we have got some indicators, right? So what are basically these indicators, right? An indicator simply it's a dye, dye dye, that changes color when it is put into an acid or a base. What did I say here? That indicator, it is a dye that changes its color when put in acids and bases. Okay, so this indicator, it basically tells us
It is
whether the
a
substance we are
lit-
testing is acid or base by changing its color. Yeah, someone was saying in something. Yeah.
I was saying that it is a type of litmus paper.
No,
We can see.
litmus paper. No, it is actually one example of an indicator used for testing acids and bases, guys. Okay.
Litmus is a natural dye, right?
Yeah, litmus is a natural dye. It is obtained from natural source, right?
Yes, sir.
Okay. So indicators are also of two different types. One is a natural indicator, one is a synthetic indicator. Getting it? Okay.
Yes, sir.
So some of the indicators here I'm listing here. Okay. So indicators, they are natural and they are synthetic also. Okay. Now, some of the natural indicators. Have you guys ever observed that let's say if you ate something and the food basically fell onto your clothes, and if you were to wash that cloth, basically the stain of the cloth, and if you were to put washing soda on it, washing soda that is a base, the color changes now, right? For example, you have a shirt here and there's a stain on it. There's a stain on it. That is of food. And the food that is cooked at home, that normally consists of turmeric. That consists of turmeric. And turmeric is yellow in color, we know that. And
Yes,
if you
sir.
were to wash this cloth, the color of this stain will change to red. Ever observed that? So this change of color basically signifies that the substance here, is a base. So this turmeric powder can also be used as a natural indicator. Why? Because when this turmeric or when washing soda was put on this turmeric, the color changed. Washing soda, I'm basically referring to washing powder. All right.
Okay, sir.
Okay. Apart from it, also we have example of litmus paper, as one of you mentioned, right? So you have example of turmeric powder, right? Then litmus. Then you have one more example, China rose. China rose. Okay. Then we have got example of synthetic indicators as well. For example, naphthalene. Yeah, you guys have seen naphthalene, right? You must have used this. Normally, it is kept in clothes, right? So that fungus and insects do not grow. Okay. Let's talk about this litmus, right? Now, you guys already know that in nature there is a symbiotic relationship between algae and fungus, right?
Yes, sir.
That we call as what?
Lichens.
Lichens. And in fact, this lichen shows, in fact, this lichen is an indicator of pollution. So in very polluted regions, you will see that lichens will grow. Not everywhere, but in certain polluted regions, we will see that this lichen is found to be growing. So it is a natural indicator as well, right? Okay.
Yes, sir.
Now, here it says that litmus is a naturally occurring purple indicator which is extracted from lichens. Getting it? Now, when
Yes,
it is
sir.
added to an acidic solution, it will change its color to red. So naturally, the color is purple, but when it is added to acid, it turns into red. Okay, and when added to a basic solution, it turns blue. Okay, so we don't take the solution form of this lesion. Instead of that, we convert it into a paper-like form. Getting it?
Like,
Yes.
I didn't get that.
Okay, look here. It says that when you take this lichen here, okay, so out of this lichen, litmus is extracted here. So naturally, the color of litmus is purple. The natural color here is purple. All right. So further, what is done now? This litmus paper is made into two types. One is basically a blue litmus, and the another type of indicator that we make using this litmus, it is the red litmus. So these basically comes in paper like form now. Getting it? Okay, so
Yes, sir.
when this blue litmus is added into acids, it color changes into red, right? And when it is when this red litmus is added into a base, its color changes to blue. When the red litmus is added into the base, its color changes into blue. So
Blue.
that's how we use this litmus paper for as an indicator to identify acids and bases, right? Okay, so here you have got no the solution form of lichens here, right? And another example, you guys know, another example is a China rose. So you guys must have seen the hibiscus flower, no? This China rose is also called as hibiscus. This here, yeah, getting it?
Yes, sir.
Hmm. So this is the flower from which China rose is extracted. So how does it work? By the way, this China rose is also called as budhal. Also, have you guys heard of this term? Hmm? Budhal. Hmm?
No.
Yes, sir.
Okay. Now, China rose indicator is basically a light pink colored solution. So from this flower, we take out a light pink colored solution. Getting it? And we mix it into water. Okay. Now, what happens?
Okay.
Here we have got the solution. See this one here. I think this is the middle one here. Light pink solution. That is basically the China rose solution extracted from this flower. Getting it? Hmm. Now,
Yes, sir.
further, you guys will see when acid is added into this light pink solution, the color changes to deep pink color. That is magenta. Okay. And when bases are added to China rose indicator, its color changes to green. Getting it?
No, sir, I didn't get that.
Okay. Let's say you, let's take a, okay, not enough space here. Okay, let's say you have got China rose indicator in this. Let me see if I've got a pink color. Yeah. Okay, that is light pink color. China rose indicator. Where are we getting this from? Basically from the China rose flower, right? And we have basically made into solution form by adding water into it. All right. Okay. Now, if you were to add few drops of acid in it, let's say you are not adding acid, few drops of acid into it. So the color will change to magenta color. That is deep pink color. That is deep pink color. Let me show you. Yeah. Notice the difference here. Huh? Sundus and Vaiga?
Yes, sir. When we add acid, the color changes, right?
Exactly. So earlier the color was what? It is light pink here. The color is light pink here now. Now the color changes to magenta color here. Magenta, that is dark pink. Is that clear now, Sundus and
Yes,
Vaiga?
sir. Yes,
Yes.
sir.
Okay. Okay. Now let's take base here. Rather than taking the acid, now let's take a base here. So if you were to take a base here, and now you have added, okay, we will have to redraw it. Right. Now you have added some bases into it. Now, what will happen? The color will change to green now. The color is going to be changed to green upon addition of base.
Okay, sir.
All right. Okay.
Yes, sir.
Okay. Is Sundus here or not? Yeah.
I'm here, sir.
All right. So that is how basically this red China rose indicator works, right? Okay. Hope that is clear.
Yes,
Okay.
sir.
Shall we move ahead then?
Yes.
Okay, sir.
Yes.
Yeah. Now, one more thing that is left here. The turmeric. How do we use turmeric as an indicator? Okay, that is also called as haldi, right? So you must, as we discussed earlier, that turmeric will basically turn the basic solutions into red. So if you take some turmeric powder, okay, and add few drops of acid into it, the color will change to red. Its color will change to red. So turmeric is another natural indicator here, which is very bright yellow colored powder, and that is obtained from a plant, right? Okay, and we know that it basically turns red when an acid solution is when a basic solution is added to it, right? Now, what if you were to add acid into it? Hmm? What if we were to add an acidic solution in the turmeric? It will
It will turn red.
remain, no, it will remain same. Let
Because
me write it over
the
here.
turmeric is the color.
Okay, just let me add one more slide over here, guys. All right. Okay, because there's not enough space. We were talking about turmeric. Bright yellow colored powder obtained from a plant. Right. Now, if we were to take few drops, few powder, few amount of turmeric powder, and if we were to add acid solution, the color changes to what?
Red.
Remains the same.
Red. The color changes to no. We were talking about basic solution first. Now, okay.
Yes.
So
Yes,
for
sir.
basic solution, the color changes to red now. Now, if you were to take a acid solution, what will happen?
It remains.
It remains the same.
It remains the same. Turmeric powder remains same. That is, the color will still be yellow. Right. So that is how you can check for the presence of acid, but it is not always reliable. Getting it? It is not always a reliable source. Hence, natural indicators are preferred, but chemical indicators are also preferred. Right. Okay. So that is it. Now let's take another type of indicator that is chemical in nature, that is naphthalene. Okay, so naphthalene is basically a synthetic acid base indicator. It is man-made. Okay, so naphthalene balls you must have seen at your homes. Getting it? These comes in ball-like forms or also comes in solutions. Okay, Now, how does this naphthalene reacts in acids and bases? Look here. Naturally, it is a colorless solution. Okay. But in an acid solution, its color changes to pink red. In an acid solution, turns pink to red as the solution becomes alkaline. Yeah. Getting it? So naphthalene
Yes.
indicator
Yes, sir.
will be colorless in acid solution, while in basic solution, it will be pink in color. Hope that is clear.
Yeah.
Turns pink to red as the solution becomes alkaline. Okay. And it is a synthetic indicator and is used for the neutralization experiment. So let me sum it up here. One thing is that naphthalene is colorless in acid solution. Now, guys, why I have not written acid only rather than writing that I have written acidic solution?
Okay.
No, my question, that was a question that why I have written acid solution instead of writing acid only here. Because any indicator which we use, that will only work on acids and bases when the acids and bases are in solution, in liquid state. So if we were to take acids or bases in dry state, in dry form, then the indicators will not be working on that. Is that clear?
No, sir. I didn't
Okay.
understand that.
Okay. Now let's say if you were to take HCl, okay, and evaporate the water from it. Evaporate the water out of it. Now it is in dry, let's say that is dry HCl. And if you were to use a litmus paper, the litmus paper will not change its color. Why? Because this does not contain water in it. It is not in solution state. Getting it?
Okay. Yes.
Litmus, blue litmus does not turn red. Is that clear?
Yes.
Okay. And this experiment, in fact, you guys can carry at your home as well. All right. Okay. Now, what
Okay.
about those substances which does not changes their color? The substances on which no indicators have, the substances you see which have no effect on any indicator. What do we call them as?
So what's the question?
My question is that, like, you have some substances which have no effect on any indicator. They are basically neither acidic nor basic. So what do we call them? Neutral substances, no? Neutral substances. Like for example, water. If you were to dip either a red litmus paper or either a blue litmus paper, the color will not change. Why is it so? Because it is neutral in nature, neither acidic nor basic. Also, you have example of common salt. If you were to take common salt solution, in that also there will be no change on any indicator. Or also take pure water or distilled water as well. In fact, sugar, that is also a neutral substance. So on neutral substances, there will be no effect on indicators. Getting it? Okay.
Yes, sir.
Now you have some examples of indicators which are olfactory in nature. So what are olfactory indicators? Olfactory basically are those indicators whose smell changes when they are mixed with an acidic or a basic solution. Whose smell changes. Take the example of onion here. If you were to add acid in onion, the color, the smell of the onion will remain same. Okay. What if you were to add basic solution on onion? The smell will be lost. Getting it?
Yes, sir.
Okay. Another
No.
example of olfactory indicator is a vanilla extract. Now,
And
if
again,
you were
sir.
to add acid on it, the smell remains same. If you add base on it, the smell is lost. Here again, same is the case with clove also. So if you take a clove oil and if you add acid in it, the smell remains same. Or if you were to add a basic solution, the smell is lost. Okay, so remember this chart here. All right,
Okay, sir.
and the examples as well. Okay, then. Any confusion so far? Yeah.
No, sir.
Okay. You guys give me two examples of strong acids.
What, sir?
Give me two examples of strong acids. In the previous class, we discussed that acids are of two types. One that is a weak acid or natural acid, or we also call them as organic acids. And another example is a synthetic acid or man-made acid. So man-made acids are strong in nature, while the organic acids are weak in nature. So I'm asking for two examples of synthetic acids from both of you.
The stronger, I think, so is sulfate acid.
Good. Sulfuric acid and
So hydrochloric acid
hydrochloric acid. Good.
and nitric acid.
Which one?
Nitric acid.
Citric acid. No, citric acid is present in citrus fruits like lemons, oranges.
NIC.
NIT. Yeah,
Yeah,
that is an example.
NITRIC. Nitric
Mhm.
acid.
That is good. Nitric acid. HNO3. Good. Okay. What are some
Okay.
examples of organic acids? Like you have the acid found in the ants sting.
Tartaric acid.
No, that is different. It's formic acid. I'm talking about the organic acid or the weak acids. In the ant stick, you see you have formic acid. Okay. Citric acid is another example present in citrus fruit,
Okay, sir.
right? And then you have example of lactic acid. Okay. Where is it found, Sundu Sanvaiga?
In
What,
milk.
sir?
Lactic acid is found where?
In milk,
Milk.
I think so.
In sour milk. Sour milk and curd. Okay. Tartaric acid, the example which you gave here. Okay. It is found where? You know, Imli? Imli, you guys know?
Yes.
Tamarind?
Yes, and so I
Yes.
guess grapes.
In grapes. It is found in grapes
Yeah.
as well. Good.
Okay, sir.
Grapes. Also in unripe mangoes. Unripe mangoes as well. It is found there as well. So these are some examples of organic acids, right?
Yes, sir.
Okay. Okay, then. One more example was there. One more example was there. You guys know palak saag, that is spinach. Let me write it over here. In
Yes.
spinach, the type of acid found is called as oxalic acid. Yeah. So at least remember 3 to 4 examples of organic acids as well, right?
Okay, sir.
Okay. Now let's move further then. Okay, now let's talk about neutralization in our daily life. Okay, so where do we see examples of neutralization? For example, if you are suffering for indigestion, so we normally take antacids, right? So one example of antacid here is a milk of magnesia. Okay, so acidity, it is basically due to extra secretion of HCl in our stomach. You know, the walls of our stomach secretes an acid called as HCl, right? And this HCl is strong enough to melt an iron nail. This is so strong. While the effect of HCl is countered by a secretion in the stomach, that is mucus. So mucus basically protects the inner lining of the stomach from the action of this HCl. Now,
Yes, sir.
suppose if there is too much secretion of HCl, that's why it leads to acidity in the stomach. Okay, so the effect of the acid will be countered, will be neutralized by the action of base. So one example is milk of magnesia, that is magnesium hydroxide. All right, guys. Okay, that is
Okay, sir.
magnesium hydroxide here, MgOH whole 2. Now, it basically gives us relief by neutralizing the effect of excess acid produced inside the stomach. Which acid is produced in the stomach?
Hydrochloric acid.
Hydrochloric acid. Okay. Now, if you were to be stinged by a ant sting or bee, what happens? Basically, formic acid is found in the sting. Okay. So their effect can be neutralized by rubbing baking soda, which is found in our kitchens. So baking soda is basically basic in nature actually. All right. Okay. One more example you will see that in the plants. Okay. If the nature of the soil is too acidic or too basic, that also can be cured by adding proper chemicals in it. Right. Okay. So if the soil is too basic, what will be adding? If the soil is too basic, soil is too basic. So what will we add? How I go? We will add acid into it now.
What, sir?
If the soil is too basic in nature, it is not fit to grow plants on soil which is too basic in nature. So we will simply add acid into it so that neutralization reaction takes place there. And the pH of the soil is restored to normal. Okay. So see this pH scale here.
Okay, sir.
Okay. So soil grows best when the pH of the soil is neutral. Okay, one more thing has came here. What is this pH here now? What is this pH here
So
now?
can you say again? I was just disconnected.
Yeah, we were not just discussing about this here. To ensure good growth of plants, we also take into consideration the amount of acids and base present in the soil. So how do we check that? So first, the amount of acid and base present in the soil is checked using a pH scale. Now the question comes, what is this pH scale now? It is simply a scale which checks for the presence of hydrogen. Which checks for the presence of hydrogen, right? So this pH here is basically checking for presence of hydrogen. Checking of hydrogen. All right. And here there's a scale starting from 0 to 14. And in the middle way, in the mid, you have got 7. So if you were to dip a pH scale into the soil, right? So how do we basically check that? Now we don't directly dip the pH scale into here. We will take some sample of the soil. Okay, we will mix it with water in a beaker. It is in solution now. It is in a solution form now. Then we will be dipping a pH scale into it. Okay, it is not directly dipped into the soil.
Okay, sir.
Okay, Sandhu Sanvaiga. So if the color changes to red here, if it changes to dark red here, this shows that the reading on pH scale is 0, right? Now, one more thing here. If you were to move from 7 to 0, right, from right to left, if you were to move right to left, okay, the substances here are very acidic in nature. Okay, so if you are getting a reading on pH scale ranging from 0 to 7, between if it lies between 0 to 7, then means the substance is acidic in nature. And if the pH reading is above 7, then it means the substance is basic in nature. Let me quickly revise this again. pH scale is basically used to check for the presence of acid and base in the substance, or to check the strength of acid or base. Getting it? So if the substances are checked here and the color is dark red, light red, yellow, and green, then it means that it's a strong acid, right? And if the color is, if the reading is 5 or 6, or this 4, 5, and 6, if the reading is 4, 5, and 6, it means that it's slightly weaker acid. So if the color is light yellow, light green, dark green, it basically means that it's a weak acid. Is that clear to both of you?
Yes, sir, it is clear.
Sundas?
Yes.
Okay. Now, if the color were to be, if the reading is above 7, and the color you are getting is, it is purple, it is light purple, it is dark blue here. So that shows it's a strong base, right? And if the color you are getting is of sky blue color here, light blue color here, that means it's a weak base, right? So if you are taking the reading and if the pH is 7, so that basically shows that it's neutral. The substance is a neutral in nature. The substance is basically neutral in nature. So we
Okay,
basically ensure that the soil should be neutral in nature. So if there is the soil is too basic in nature, we will add some acid. If there is too much acid present in the soil, we will add some base, so that the neutralization reaction takes place there and the pH of the soil is balanced. Okay, I'm giving you a few questions here, guys. Okay, you have to tell me whether it's too strong, too strong acid, or too strong base, right? So let me write the 1,
uh,
0, 1, 2, 3, 4, 5, 6, 7. Hmm. Okay, I'm giving you few options here. For example, if the value comes 0, 1, 2, and 3, and the values are 11, 12, 13, and 14. So which reading shows that the substance is very strong acid and which one shows the substance very strong base?
so 0, 1, 2, and 3's like two strong acid, and 11, 12, 13, and 14 two strong
Hmm.
base.
Yeah. Okay. Okay. Now, Sundus, you tell me, what if the reading was 4, 5, and 6? And what if the reading was 8, 9, and 10?
It is a weaker acid or a base.
Weaker acids and weaker base. Good. Okay. What if the reading is 7?
Neutral.
Neutral.
Neutral. The substance is neutral, right? Okay. What are some other examples of neutralization reaction? Like the factory waste that is generally acidic in nature and can cause environmental damage. They need to be treated with basic substances before they are discharged into the water bodies, right? So that it does not kills the aquatic life. Okay. Okay. Some of the applications, for example, while checking the pH of soil, how basically the pH level of the soil is disturbed. So if you were to add excess amount of chemical fertilizers, that will change the pH of the soil, right? And the plants will not grow well either if the pH is too acidic or too basic, right? So substances are added to bring the pH to a neutral level. Okay, okay then. Uses of acids and bases. Where do we use acids and bases? We use basically acids for food preservation. For example, the citric acid that is used for food preservation. Okay. Apart from the examples given here, you guys list me some of the applications of acids and bases in your daily life. Mhm. Yeah.
So for this is potassium hydroxide soap,
Potassium.
hydroxide soap,
Okay. What else? The bleaching powder which we
magnesium
use.
hydroxide for milk of
Mhm.
magnesia something.
Milk of magnesia, that is um, magnesium
Magnesium.
hydroxide.
Okay,
Good.
sir.
Okay. What about the baking soda? That is
Okay.
also example. No? Okay.
Oh yeah, sir.
Now the vinegar which we use, that is also called as silica, right? So that basically consists of acetic acid, and that is used for cooking. Now the aerated drinks which we are using, aerated drinks like you have got examples of these type of drinks. Okay, these are basically aerated drinks that consist of carbon dioxide in them, right? So they consist of ascorbic acid in them, carbonic acid in them. Sorry, they consist of carbonic acid in them. And by the way, these drinks are harmful for health. Okay. Now the bleaching powder.
Sir.
In the manufacture of bleaching powder, you take help of a base. So bleaching powder, that is basically calcium oxochloride, CaOCl2, that is the bleaching powder. Now in the formation of this bleaching powder, we use a base called as calcium hydroxide. Getting it? So in the formation, you use CaOH whole 2, that is calcium hydroxide, serves as the raw material required for the formation of bleaching powder. So in your
Okay,
higher
sir.
class, you will study how the what you will be studying about the process of the formation of bleaching powder, right? Okay. Now, in fire extinguishers also, as a foaming agent, aluminum hydroxide is used. Okay. So remember the uses of acids and bases. These are some of the common uses. Getting it? Okay then.
Yes.
Okay. Litmus, we have already discussed this, right? All right. Okay. Do we have still time left? It's
So I
only
guess 3 more minutes.
3 more minutes are
Yes.
remaining here. Okay. Okay. We can discuss some questions, right?
Okay, sir.
Okay. Okay. So let's say that give me one example of a natural indicator.
What's up?
Let
Natural indicator. Give one example.
China rose,
China rose.
Litmus is also the natural indicator.
turmeric,
Litmus and
turmeric,
turmeric. Okay. Now, how does China rose work?
What's up?
Sundus, you tell me how this China rose indicator works.
I didn't understand what are you trying to
How
say.
how China rose indicator works? That is the question.
Like
Like,
that, like
what is the affected acidic
extractor,
solution? Mhm.
extractor,
No, my question is now
solution
how.
of it.
Okay, we extract the China rose solution. Okay, from the China rose flower. Okay. Now the question is that how does it work? Like in acidic solution, the color changes to dark pink now, and in basic solution, the color
Yes.
changes to green.
yes,
Right.
sir.
So this is how it
Yes.
works. Okay. And what if you guys were to add turmeric in? You guys were to add acid in turmeric. Will the color change to red or will it remain same?
No, sir, it will
It will.
remain same. And
Hmm.
if we add taste to it, it turns into red.
Exactly, exactly. That is the case. Yeah. All right. Okay, then. So that is it for
Okay.
today. Okay. Some
Okay.
more interesting concepts are left in the chapter, and the exercise part is also left. So we will be discussing that in next class. Okay.
Okay,
And by the way, the in the previous test, Sundus and Vaiga, both of you have performed very well. Sundus, I guess you got 40 out of 50, right? And
Yes.
Vaiga, you got 40.6 out of 50. Okay.
Okay, sir.
Okay. So here, just a slight bit, just by a small margin, Viger has did well, but still, you guys have performed very well. Okay. So there were some minor parts which where you guys need to improve. Okay. So
Okay,
I
sir.
would suggest that both of you start preparing for the next test now. All right.
Okay, sir. So I guess nutrition animals is the next chapter.
Yeah, that will be the next chapter.
Okay, sir.